Right, so for our next thing, we are going to talk about matrices. So matrices just give you an easy way of solving. So there are three important matrices involving a system of equations. They are the matrix A, which is your coefficient matrix, matrix X, which is the variable matrix, and matrix C, which is the constant matrix. Okay, now we're not going to use all three of these when we are solving, but you do need to understand what each of them means. Okay, so now we're going to write these in terms of matrix A. Okay, and a matrix always looks like this. It has these little lines outside of it. Matrix, oh, I call it matrix B, but it's actually called matrix X. Okay, and then we have matrix C. Okay, so really all we're doing is we're rewriting this, okay, in here. So A is just going to be our coefficients. That's why it's called our coefficient matrix. So you see for that first equation, I just wrote -10 and -3. For our X matrix, we're telling what our two variables are. And then for our C matrix, we're telling what our constant is. Okay, so now let's go ahead and do the same thing for 4x plus 5y equals 16. So that'll be 4 and 5. We already have the x and y in there, and then 16. Okay, so that's all you're doing when you're doing the matrix. Now, when we're gonna use a calculator to actually solve matrices, and we're gonna wind up not using this one right here, okay? Because that doesn't really matter a whole lot when we're solving these. So let's go on ahead and let's look at how we're gonna solve using a matrix. So when we are using matrices, we have an equation, A times X equals C. We're going to multiply both sides of the equation by the matrix reciprocal of A, which is also called A inverse, and is written, and you'll see it especially on your calculator, like that. Okay, and you can also write it as A to the -1. Okay. All right, so we're going to go on ahead and solve this. Okay, solve some equations, or at least one equation, using your calculator. And I don't mind if you use your calculator after this point. You do need to understand how to do it by hand, because there are some that you're going to have to do by hand. And I'll explain that to you in a minute. So here we are going to do 1 plus 2y minus 3z equals -28, 4y plus 2z equals 0, and -x plus y minus z equals -5. So the first thing we need to do is we need to write our A, our X, and our C matrix, okay? And you're gonna get better at this and wind up not having to actually write these out. Okay, so for our first one, that's a 1, a 2, and a -3. That's a 4, oh, see, right there. All right, so that's a 4y, so there's 0 x's. There's 4 y's, and there's 2 z's. There's -1x, there's +1y, and -1 z. Our X matrix is telling us that our variables are x, y, and z, and our C matrix is just our constant. Okay, so now we are going to just write our constants, -28, 0, and -5. Okay? And like I said, as you get better at this, you're not going to have to actually write them out every time. All right, so now we're going to actually talk about how to go into the calculator and enter these matrices. So you're going to want to hit second, and then whichever button has your matrix on it. It depends on your calculator, but mine is right above the x to the -1 key. So I'm going to hit matrix, and it's going to pull something up like this. Yours may or may not have this in it. Okay, so I'll show you how to change that in a minute. Okay. All right, so we're going to go over to edit and hit enter for A. Okay. All right, so A, this one right here, the one I was working on, was a 2 by 3. Okay, but really this right here is a 3 by 3. Okay. So it's always going to be down by across. Okay. So there's actually 3 down and 3 across. Okay, so now it's changing my matrix size. And then I'm just going to put these numbers in, hitting enter after each one. So 1, 2, negative 3, 0, 4, 2, negative 1, 1, negative 1. So now I'm going to hit second matrix again, and I'm going to go over to edit. And it doesn't matter if you use B or C. I have both of them in here because I've been working on a couple of different things. So I'm just going to choose matrix B. And in that one, I'm going to put my constant matrix. Okay, remember, I said when we're solving, we don't need that. Okay? So my constant matrix in this case is 3 down and 1 across. So that's going to be negative 28, 0, and negative 5. Okay. All right, so now we're going to solve this. So we're going to hit second quit. Okay. Now we're going to go on ahead and we're going to go, and I have all these steps written out with pictures. So we're going to hit second matrix again, but this time we're going to choose a matrix. So we're going to leave it on names and we're going to choose our A matrix. So remember, when we did this before and when we talked about solving it, we talked about how it's A to the negative 1 times this whole side and times C. Okay, this is the piece that we really want. Okay, so we're going to do A, and then we're going to hit our inverse key, which is this x to the negative 1. Okay, that pops that up, and we're going to do times, and then we're just going to go in and choose our other matrix. And in this case, we put our constant matrix as matrix B, so I'm going to choose that. Then I'm going to hit enter. And there it gives me 3 answers. So it gives me answers in the order that I put these into. So I put X, Y, and Z, so it's going to give me X, Y, and Z. Okay, so now I know that my answer here is negative 4, negative 3, 6. Okay. Now let's take a look at one that we did yesterday. Okay, so we came up with an answer yesterday. And I'm going to show you what happened. So we came up with this answer for this one with 2, 0, negative 1, and 0. And you'll notice, right, based on how we did it, we came up with some values. Okay. If we had taken this and combined these and gotten an x minus 2y plus z equals 2, okay, and we combined them and got a 3x, 3x minus, let's see, that would be minus 3y equals 1. Okay, then we would have come up with something completely different. Okay, so if we had combined these two straight away, okay, without actually getting rid of anything, okay, we would have come up with this right here. So we could actually solve for x or y right now. So we could say, well, 3x equals 1 plus 3y. Okay? And in this case, we could also then say, well, we know then that x, oh, I forgot to add my 2 and 1. There we go. So equals 3. I was going to say, why is this coming out weird? Okay, so right there. So now we can divide everything by 3, and we can get x equals 1 plus 1y. So now we could really say x equals 1 plus a. Oh, so really what you're telling me is if I plugged in different numbers than 0, negative 1, 0, this would actually work. Okay, but because of the way we solved it, okay, it came out showing us that it's y equals negative 1. Okay, so, and if you plug these values in, they do work. Okay, but in this case, this is actually a consistent dependent system. Okay, but I wanted to wait until today to show you this because I want you to see when we're using our calculators, how you would actually figure that out on your calculator. So on my calculator, I'm going to go on ahead and I'm going to solve this matrix. Okay, so I'm going to write, I'm going to do second matrix, okay, and I'm going to edit my A matrix. So it is only going to be 2 down by 3 across. So I'm going to enter 1, negative 2, 1. And then I'm going to enter 2, negative 1, -1. So I'm entering my coefficients here. Now I'm going to do second matrix again, and I'm going to go down to whichever matrix I choose. Okay, so, oh, I didn't choose edit. Oh, second matrix. All right, there we go. We're going to edit our second matrix. Okay, this is only going to be a 2 by 1, so it's 2 down and 1 across. So that's going to be a 2 and a 1. Okay, so now I'm going to solve this. Okay. So second matrix, I'm going to choose my A to the -1 times, and I'm going to choose my B matrix. Watch what happens. Oh, it gives me an error. So if I ever get an error, okay, on my matrix, okay, when I'm solving this via matrix, it means that it is either, so an error means that it is either a dependent, so a dependent, consistent dependent solution, consistent dependent, or it is no solution, so an inconsistent. Okay, so you don't know which one though, so you still have to be able to solve these by hand. So if you get an error, you want to go on ahead and do this, okay, and solve it by hand. If we had solved it this way, okay, and we already had done our matrix and know that it is, that it gave us an error, but we got an answer when we solve it, then we know that we can actually plug this in and say, oh, well, if this is A, then this is A -1, and this is A, because those values are the same. And solving it here, that's what you're going to see also. Okay, so you're going to get, so it's very similar to what we got. So x equals 1 plus A, but if I had solved for y here, I would have gotten, so if I'd solved for y, right, let's solve for y, 3x minus 3y equals 3. Okay, so I'm going to go on ahead and subtract 3x from both sides, okay, and I get y equals A -1. Then I could plug that A -1 back in, okay, get my x value, and then plug it back in and get my z value. Okay, so it's just a check. Okay, so this one that we did yesterday, yes, this was a correct answer, but there are actually multiple correct answers. So because of the way we solved it, we only got one of the correct answers. Okay, so that's why I'm teaching you matrices, because solving with matrices is going to make your life a whole lot easier. Yes, there's some stuff you will have to do by hand, but you can at least start out with matrices and see, you know, is it one answer? Is it possibly no solution, or possibly consistent dependent, meaning all infinite solutions? Okay, so going ahead, do your form today using matrices. Some of these you might have to go back and solve by hand if it gives you an error. And I will see you all tomorrow.